Hello and welcome to my channel. In this video series, we are going to create Tetris game in C programming without using graphics library. At first, let me show you the final game. We can move shapes using left and right arrow key and rotate it clockwise using top arrow key and rotate it anti-clockwise using down arrow key. Also, we can see next Tetrimino and total score and total number of rows completed. Here I created these shapes by just printing hash character and this border by printing special hexadecimal character. Alright, this is a final game. Let's discuss about it in details. Before starting, please check video description. I have provided link to download source code of this game and this blog. Also, please do not forget to subscribe my channel to support me. In this project, you will understand the implementation of linear algebra in game development. Linear algebra is the foundation of physics, simulation and object transformation, especially in 3D game. As this is simple 2D game, we will use very basic part of it. We will implement 2D XY coordinate system origin point at 0, 0. We will use rotation and translation vector to rotate and translate shapes on the XY panel. Also, I will discuss creation of required data structure and techniques to detect collision and calculate score. I have divided tutorial in two parts. In first part, I will explain the all type of shapes, game coordinate system, rotation and translation vector. In second part, I will explain the data structure, collision detection and score checking techniques. Now let's discuss first part. I'm using all 7 shapes, and in some game you will find only 5 shapes, but here I'm using all 7 shapes. And like some game do not use J and S shape, they use only I, L, T, Z and O shape. Here each shapes are created using 4 block, and each block is called Mino, and collection of 4 Mino is called Tetrimino, and some says Tetramino or Tetrimino, but here I'm using Tetrimino word. So throughout the video I will refer a Tetrimino to the shapes. So this one is I Tetrimino, JLTZOS, and the beauty of this game is all Tetrimino have exactly 4 block. So, and this is also a very interesting part of the game, and it will also make game development very easy. Now let's discuss coordinate system. To implement coordinate system, I am using go-to-xy function. This is Windows function. The go-to-xy function move the cursor on the command window, and at that location we can print the character. So let me show you by running the game. So here I'm using go-to-xy to move the cursor here and print the character. So that's my logic. And however, the center of go-to-xy function is here at the top left corner of the command window. So here is the 0, 0, and to our right side is the x coordinate, positive x coordinate, and to our downward is the positive y coordinate. It looks very odd and it makes game development very difficult. So to simplify game development and to simplify shape drawing process, I have shifted center somewhere here. So I have shifted center toward 36 x-axis and 12 y-axis, 12 unit toward y-axis. So now our new center is somewhere here, and positive x-axis will be right side and negative x-axis will be left side, and upward is the positive y-axis and downward is the negative y-axis. And to implement that, I'm using offset number 36 and minus 12. I will show you how it works. So here, whenever we pass value inside xy, go to xy function, I will sum that x by 36 and subtract y by 12. So this way I'm able to shift the center at 36x and 12y position. So for example, if we pass 36 minus 36 and 12 in a go to xy function, so it will be equivalent to original 0 0 coordinate. So it is same as the top left corner of the window. So here let me show you this picture. This is the final coordinate system. So here let me magnify it. Okay, so this is the final shape. Okay, so here now our center is here. Okay, and right side is a positive y-axis, left side negative x-axis, upward is the positive y-axis, and downward is a negative y-axis. And our size of the window is around 11 unit along x-axis. So positive 5 unit toward positive x-axis and negative 5 unit toward left side, so negative x-axis. And similarly length is 21 unit toward y-axis, so upward is positive 10 x-axis and downward is negative 10 x-axis. So it looks very longer toward y-axis because our window is not a graphics window, it is a console window. It's for displaying text. So you know the line spacing is more downward in the command window. That's the reason it looks very longer. So we can't do anything about it. So this is our final coordinate system of the game. Now let's discuss rotation and translation of Tetrimino. When we display Tetrimino on the screen, it means we hold the coordinate of Tetrimino. So translating Tetrimino means we are translating coordinate of Tetrimino. Here translation vector is very simple and the overall formula is also simple. We simply need to add the translation vector in an initial coordinate to get the final coordinate. Here let's say b is initial coordinate xy and t is a translate coordinate x dash and y dash. Then the final coordinate b dash will be b plus t, that is x plus x dash and y plus y dash. Now if we have to translate coordinate 0 0 by using translation vector 0 12, then the final coordinate will be 0 12. So this is the overall translation formula. Now for rotating coordinate, the rotation vector is r, that is cos theta minus sin theta for the x coordinate, and for y coordinate value is sin theta plus cos theta, and the final coordinate is r dash r cross v. So that is x cos theta minus y sin theta for the x coordinate and x sin theta plus y cos theta for y coordinate. However, we rotate Tetrimino only by 90 degree, so cos theta will be 0 and sin theta will be minus 1. So the final rotation vector is y cross minus 1 for final x coordinate and x cross 1 for final y coordinate toward anti-clockwise direction. And for clockwise direction, the final coordinate is y cross 1 for the final x coordinate and x cross minus 1 for final y coordinate. So this is the overall anti-clockwise and clockwise vector. In game, we will use minus 1 as an anti-clockwise vector and 1 minus 1 as a clockwise rotation vector. Now for example, if we have to rotate 2 3 clockwise, then the final coordinate will be 3 minus 2. So this is the overall concept regarding translating and rotating Tetrimino. Behind the scene, we actually rotate the coordinate, not the shape. Now let's take a line Tetrimino as an example and understand the concept of rotating and translating it. Here at the initial position, we display Tetrimino at the center. So here for the line, we display shape this way. So overall coordinate will be 0 2 at the top and 0 1 0 0. A third box will be the center and 0 minus 1 is the last one. So we always display we always have a Tetrimino in the center of the coordinate. So our initial coordinate of Tetrimino will be at the center. And at first we will check the rotation vector. So if rotation key is provided by user, then we will rotate the Tetrimino. So let's, here as example, let's rotate Tetrimino by clockwise. Then the final coordinate will be -1 0 from left side. The final coordinate will be -1 0 0 0 1 0 and 2 0. This is the final coordinate after rotating it clockwise direction by 90 degree. And after rotating, we will translate it by -3 7 translation vector, and the final coordinate will be -4 7 -3 7 -2 7 -1 7 from left side. So this is the overall and final coordinate of Tetrimino, and we will display Tetrimino at this coordinate. And this happens in every frame. So every time when we display Tetrimino on the screen, at first we have a coordinate at the center, and we will check the rotation vector. If there is rotation vector, then we will rotate, and as per the current translation vector, we will translate the coordinate at that translation vector at that location, then only we will display. So every frame this happens. So let's say if there are 6 or 7, for example, let's say there is a 10 frame in per second, then 10 times we will check the rotation vector and we will translate it. So this happens in background, and this happens very fast, so user will not notice. Okay, and yeah, this is the final concept of rotation and translation. Now let me discuss about go-to-xy function source code. I will discuss other source code in second part, but here I will discuss only go-to-xy function. Inside go-to-xy function, I'm using 36 and 12 offset value. So whenever we pass value in a go-to-xy function, I will sum x coordinate by x offset value, that is 36, and then I will multiply y coordinate by -1 and sum the y offset value, that is 12, and this way I will flip the coordinate of y-axis. So as you know, for the window and for the go-to-xy, downward is the positive y-axis. So by multiplying y by -1, I'm switching it, and downward will be negative y-axis and upward will be positive y-axis. So this is the overall logic that I have implemented with our inside go-to-xy. And yeah, this was for this video. In second part, we will discuss about data structure, collision detection, and we'll discuss the source code in details. See you in next video. Bye bye.